Hello everyone, welcome to Neso Academy. In this lecture, we will understand references in C++. So without any further delay, let's get started with this lecture and let's see what are the topics. The first topic of this lecture is Introduction to Pointers. First, I will introduce you to pointers because understanding the basics of pointers is quite important for us to properly understand the concept of references. After getting the basics of pointers, we will then move to the second topic where we will understand references properly. And after understanding references, I will give you some important points about references as well. So these are all the topics we have in this lecture. Let's start with the first one, Introduction to Pointers. So what are pointers? A pointer is a variable that stores the address of another variable. So think of it as a special kind of variable which has the capability to store the address of some other variable. We know that normally a variable can hold a value, but pointer is a special type of variable that can hold an address. Now here is the syntax of the pointer. This is how we can define a pointer. We can first specify the data type of the variable which is pointed by the pointer. So if we want that the pointer should point to a specific variable, then we need to provide the data type of that variable first. Then after this, we can provide the asterisk symbol. This asterisk indicates that we have a special type of variable called pointer. We do not have a normal variable here. After this, we can specify the name of the pointer and then at the end we can put a semicolon. In this way, we can define a pointer. Now let's understand through an example program how to use pointers in C++. Here is the example C++ program. Here I have included the IOStream header file because I am using stdcout. Inside this main function, I have defined variable a of type integer with value 10. This variable is a normal variable and it is holding value 10. So we can imagine a box like this which is holding value 10 and a is the name of this box. This is how you can imagine a variable. In reality, this is not a normal box. It is some memory location where value 10 is stored. Now here I have defined this pointer variable. This is not a normal variable. As we can observe, we have this asterisk symbol after this data type. This clearly indicates that we have a pointer here. Before this asterisk, I have specified the data type which will be pointed by this variable pointer. Here I want that this pointer must point to this specific variable, and we know the type of this variable is int. That's why I have specified int over here. I hope this is clear to you. Then after this asterisk symbol, we have this name of the pointer p, and then within braces, I have specified %a. Now, what is the meaning of %a? Ampersand is also called the address of operator. With the help of this operator, we can access the address of some variable. Here I have specified %a. This means I am passing the address of this variable a to the pointer p. We know pointer p has the capability to store some address of some variable. So clearly, here I want the pointer p to point to this variable. That's why I am providing the address of this variable. This variable has some memory address. Now pointer p will hold that address. This clearly means that pointer p now points to variable a. So this is the concept of a pointer. Now pointer is pointing to variable a. This means with the help of this pointer, we can access this variable a, And we can even modify this variable a if we want. Now, after the definition of this pointer, I have written this std_cout statement with variable a. This means, here with the help of this statement, I want to display the value of this variable a. Value of this variable a is 10, it will be displayed. Then after this, I want to display the value of p. We know p is the pointer and it has the address of this variable a. So the address of this variable a will be displayed. Then after this, with the help of std_cout, I want to display the result of asterisk p. Now what is the meaning of this asterisk p? If we specify asterisk after the data type in the definition of the pointer, then it means that we are defining the pointer. Now here, if we specify asterisk and if we provide the name of the pointer, then this asterisk behaves differently. This asterisk is also called the indirection operator. This allows us to access the content of the variable which is pointed by the pointer. Here we have specified asterisk p. This means we want to go inside of this variable a and we want to access this value. And therefore, we will get 10 on the screen because of asterisk p. I hope this idea is clear to you. So when we execute this program, we will get this output 10, then the address of variable a. This address can be different in your machine. I am getting this address in my machine. After this, we will get 10 because of this asterisk p. I hope this program is completely clear to you. So with the help of this program, we have learned the basics of pointers. We learned how to define a pointer. In this way, we can define a pointer. We have also learned how to initialize a pointer. We need to provide the address of some variable to a pointer, and this is exactly what we have learned here. And if we want to access the variable, that is the content of the variable, then also we have learned what we need to do. So with this, we are done with the first topic, that is introduction to pointers. So I can check this. Now let's move to the second topic to understand references properly in C++. So what are references? A reference is an alias for a variable. So it is just another name for a variable. It is not another variable, it is just a name given to some variable. And with the help of a reference, we can access or modify a variable as well, just like a pointer. We learned just now that with the help of a pointer, we can access a variable and we can modify the variable as well. And pointer itself is a variable that has the capability to store the address of some other variable. But reference is not another variable. It is just a name given to some other variable. So think of it as a nickname for some variable. Now, with the help of this name, we can access that variable and we can even modify that variable. Now, let's see how to define a reference in C++. Here is the syntax we need to follow. First, we need to specify the data type of the variable for which we want to create the reference. And then after specifying the data type, we need to provide the ampersand symbol. This is the syntax we need to follow. We learned in case of pointer, we need to provide asterisk. In case of reference, we need to provide ampersand. After this, we can provide the name of the reference. And then within braces, we can provide the variable for which we want to create the reference. So we will provide the original variable within braces. So in this way, we can initialize the reference. And then at the end, we need to provide the semicolon. So that's the concept. This is how we can define a reference and even initialize it. Now let's understand how to use a reference in C++ with the help of a C++ program. Here is the C++ program I have written for you. I have included the IOStream header file, and inside this main function, I have defined variable a of type integer with value 10. After this, I have defined this reference. Now, why am I calling this a reference? Because this reference is following the syntax. Here, I have specified the data type, which is the data type of this variable a, because for this variable, I want to create a reference. After this, I have specified the ampersand symbol. This is exactly what we need to do. Then after this, I have provided the name of the reference, which is ref in this case. And within braces, I have passed this variable. Notice how the syntax is different from the syntax of the pointer. Here we are directly passing the variable. We are not passing the address of the variable. This is how we can initialize the reference. I hope this is clear to you. Now we have another name for this variable a, which is ref. With the help of stdcout, I am trying to display the value of a and value of ref. We know a and ref are the names of the same variable. Therefore, we will get the output as 10 and 10. I hope this is clear to you. Variable a is holding value 10. Now, ref is just another name for this variable. So, for this specific ref also, we will get 10 as the output. Now, with the help of reference, we can also modify this variable. We can provide a different value to this variable like this. Here, with the help of assignment operator, I am trying to update this variable. Here, I am providing value 20 to this variable. So, at the end, we know this variable will hold value 20. Now, if we try to display the values of a and ref, we will get 20 and 20. I hope this is clear to you. So, this is the concept of a reference. And reference is quite easier to define as well because it follows a basic syntax, which is quite easier to understand. So now we know what a reference is. Now here is the important point you need to remember. Unlike pointers, reference is not a separate variable. As I have mentioned this already, reference is not a separate variable that we create. It is different from pointer. When we define a pointer, we create a variable, and that variable has the capability to store some address. But reference is not a separate variable. It is just another name given to a variable. I hope this is completely clear to you. So with this, we have understood the basics of references. This means we are done with the second topic also. Now let's understand some important points associated with references. Here is the point number 1. Reference must be initialized when declared. When we declare a reference, we need to initialize that reference. In the syntax also, we have observed the same thing. We cannot define a reference without initializing it. Now, here is the example to understand this properly. Here in this example program, I have defined this reference R, but I have not initialized this reference. In other words, I have declared this reference. Now, if we try to print the value of R, then we will get error on the screen because this reference is not initialized by some variable. Now, if we want to initialize it, then we need to provide some variable within braces. I have already defined this variable x, so we can provide x within braces after the name of the reference like this. Now, this is the correct program. In this case, we will get 10 as the output because r is just another name for this variable x. Now let's move to point number 2. We have understood point number 1. A reference cannot be changed. Once a reference is defined for a specific variable, we cannot change it. For example, let's say I have written this C++ program. This is the basic C++ program. Inside this main function, we have just return 0 statement. Now, let's define variable a with value 10 like this. We can think of it as a box with value 10 and the name of this box is a. Now, let's define variable b with value 20. We have another box with value 20 and the name of this box is b. So now we have two boxes with values 10 and 20. Now let's define a reference like this. This is the reference to variable a. So clearly we now have another name for this variable a, which is r. Now let's say I want to change this reference. I want to make this the reference of variable b, but I cannot do this in C++. If we write something like this, r equals b, then it is not the case that r becomes the reference of b. Here, this r can be replaced by a because r is just another name for a. So here we have a equals b. This means the value of b will be transferred to a. In other words, we will get the copy of this value in the variable a. So now we can replace 10 by 20. So now this variable a is holding value 20. But we can also observe that r is still the reference for this variable a. Because once we defined reference for a specific variable, we cannot change it. That's the point. Now if we try to display r, we will get value 20, not because r is the reference for b, but r is the reference for a and a is currently holding value 20. We can verify this as well by displaying the addresses of r and a like this. Here we will get the output like this. In my case, I am getting these addresses, and one thing to note here is that these addresses are same. This means R is the reference of A, not reference of B. So with this, we have understood all the important points associated with references. This means we are done with the third topic also, and we are done with this lecture. Okay friends, this is it for now. Thank you for watching this lecture. I will see you in the next one.